MLOps is about people, process, and tools. Let's spend some time on the latter of these. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, we talked about MLOps at a high level and walked through one maturity model. We hit repeatedly on people and processes throughout that video, as these really are the two most important parts of DevOps, DataOps, DevSecOps, MLOps, whatever ops. Today, we are going to focus on the third part of that triangle, tools. In the Microsoft ecosystem, there are two products which work really well for implementing MLOps, Azure DevOps and GitHub Actions. Both of these products allow you to automate training, testing, and deployment of machine learning models to an Azure Machine Learning workspace. These are both tools for continuous integration and continuous deployment, or CI/CD. Now, as an aside, I really love annoying Microsoft Cloud Solution Architects by asking them, given that Microsoft owns two major CI/CD tools, which of the two is the right one for the job? If you force me to answer that question, I'll probably hem and haw about as much as they do, because the answer seems to flip about once or twice a year. There was a stretch of time in which GitHub was the end goal, that we were seeing advice to move away from Azure DevOps and onto GitHub Enterprise. But it seems like that trend has reversed a bit, and the guidance is back to saying that there are two platforms with somewhat different experiences, and which one is the best fit depends on a variety of factors, including what do you have experience with in the past, or whether you're already using GitHub for source control, maybe security requirements, things like this. Because I have all of my repos in GitHub, I'm going to take the easy way out of this debate and simply use GitHub Actions. I will also provide a link to a Microsoft Cloud workshop on using MLOps with Azure DevOps in case that's your preferred route. And if you want to talk about the Azure DevOps scenario in a future video, leave a comment, I'll record that video. Now that we've landed on GitHub Actions, I'm going to spend the demo portion of this video preparing the battle space, both in Azure and GitHub. But before I get there, let's go to the drawing board. At a really high level, what we want to do is link up our GitHub repository in such a way that we can execute Azure ML pipelines using GitHub Actions workflows. Here's a quick and dirty architectural diagram explaining what we're going to need. We already have an Azure Machine Learning workspace, but I am going to need to know certain details about it, such as the subscription ID and the resource group name. Those are easy to get from the overview page in the Azure portal. I'm also going to need a way for an external resource, specifically the GitHub runner, to connect to Azure Machine Learning and kick off those pipelines. We need some sort of authentication token to indicate that we are in fact who we say we are, and that we are authorized to run pipeline jobs in Azure ML, as we don't want just any yokel running them. No, we only want authorized yokels to run them. There are two valid ways we can do this, and both require that we create some sort of principal in Azure Entra ID, which you may also know as Azure Active Directory. The name change is in progress as of the time of this video recording, so some of the documentation will say Azure Entra ID, a lot of it still says Azure Active Directory. It's the same product, and far be it for me to derail a video by ranting about Microsoft marketing changing the name of a product after several years and thereby sowing the seeds of confusion. That definitely doesn't sound like something I would do. Anyhow, like I said, there are two valid solutions here. The easy route is to create a service principal, such as a managed identity. This is fine for security, and if I walk into a shop and they tell me they're storing the service principal credentials as a GitHub secret, I'll say, sure, sounds good. But there is a better approach, using OpenID Connect. This uses short-lived tokens to provide authorization, meaning that we don't need to store any credentials in GitHub. Instead, we configure an OpenID Connect trust on Azure, and the workflows are authorized to request a short-lived access token that they can use for their purposes. Even if one of these tokens gets exposed, it limits the risk that an attacker can do much against your system. For that reason, we are going to go with the OpenID Connect approach. The basic idea is that we will need to register a new Entra ID application registration and service principal. And Azure Entra ID application registration, by the way, is not an application in the way we think of it. It's not some executable code which provides a service to us. Think of it instead as a way of telling Azure Entra ID that there's some sort of account we're going to want to tie to an Azure service. After we create the application registration and the service principal, we are going to need to identify a role assignment for Azure Machine Learning. That way, the service principal will be allowed to access relevant resources. We're going to use the contributor role. That will be enough for us to kick off AML pipelines, so it's good enough for us for this demo. Once I do that, I can store 3 things in my GitHub repository as secrets: the application registration ID, the Azure Entra tenant ID, and the subscription ID for my Azure Machine Learning workspace. With those secrets in place, we can then create GitHub Action workflows. Each workflow has a trigger, and when that trigger executes, it spins up a runner. GitHub runners are virtual machines hosted in Azure, and we can use them to execute code. Specifically, we'll execute the code we built when training a code-first model. That's the high-level view. Now let's go to a demo and get everything set up. This demo is all about creating a secure link between Azure and GitHub. Starting in my GitHub repo, I'll navigate to Settings. Then, let's drill into Secrets and Variables and choose Actions. We can see a trio of secrets: a client ID, a tenant ID, and a subscription ID. I'm going to be able to use these 3 to communicate with an Azure ML workspace. Specifically, in the Azure Machine Learning IAM portal, we can see a service principal which has contributor access to resources in the workspace. We'll be able to use it to execute machine learning pipelines from GitHub. Now let's see how we can set this up. Here we are in the Windows terminal. Not normally where I'd start a demo section, but this is something I wanted to show you how to do using the AZ CLI tool. You can, of course, do all of this work in the Azure portal as well, but let's stick to the command line today. I'm going to need 2 variables early on: my Azure subscription ID and the resource group name hosting Azure Machine Learning. I already set the subscription ID beforehand in a variable called $subscription ID, so that's why you only get to see the resource group name here. The next thing we're going to do is register a new Azure Entra ID application registration. I'll call this Chicago Parking Tickets MLOps GitHub Video Demo. That's a rather verbose name, but at least it gets the point across. As I run this command, I'll get back a block of JSON text. From here, there are 2 things in particular that I need. The first of these is the app ID, which we'll eventually use as our Azure Client ID secret. I'll copy the GUID here and store it as $app ID. The other thing I need is the value in the ID field. I'll copy this into a PowerShell variable called $object ID, and we'll use it in a later command. Now that I have everything I need from the app registration, let's move on to the next step, and that is to create a service principal based on that app ID. This is another command within the Azure Entra ID CLI module, and I'll pass in the app ID as our required ID parameter. This also spits back out some output. From here, I'll want to grab the app owner organization ID field and save it in PowerShell as the variable $tenant ID. Note that if you're reading older documentation, this field used to be called app owner tenant ID. So if you're looking for a tenant ID, you'll want to search for the organization ID. We are going to use this ID as our Azure tenant ID secret. The other thing I need to grab from here is the service principal object ID, which is the ID field. Let's save that as $assignee object ID. With a service principal in place, the next step is to grant that principal rights on Azure Machine Learning. To do so, I'll use the AZ role assignment command and create a new role assignment. We'll grant the service principal contributor on the CS Azure ML resource group and all of its resources, including our Azure ML workspace. Note that we need the subscription ID, the resource group name, and the assignee object ID. Finally, we'll specify that the assignee is a service principal. At this point, we've done almost everything we need to do, but before we close this demo out, I want to point out one tiny thing. We are now in my GitHub repo, so let's navigate to Settings and then Environments. Let's say that I want to have two environments, development and production. For the sake of simplicity, both of them will point to the same Azure ML workspace, but I'm going to configure things as though we expect the development environment's AML workspace to be different from the production environments. Let's create these two environments right now. We could, of course, have more than just two environments, but my experience is that we typically see either one or two Azure ML workspaces at a company or an organizational unit. Rarely do we see more than two workspaces. Now that I have these environments, let's switch back to Windows Terminal. I am going to create two federated credentials, one for production and one for development. Federated credentials allow us to create a trust relationship between an Entra ID application and an external identity provider like the one GitHub uses. To create one, we'll need two things: the Entra ID app registrations object ID, as well as a set of parameters specifying relevant inputs in JSON format. Let's open up Visual Studio Code and take a look at one of these parameter files, specifically the development file. We can see in here the name of the federated credential we're going to create. Then we see that the issuer comes from GitHub. The subject explains what this credential will have access to on the GitHub side. Repo here means that we scope this to a repository, and then we specify the account or organization name, / and then the repository name. After that, I want to narrow things down further and say that we only want to use this federated credential for the development environment. The description is a bit trite, but it works, and my audiences ties back to Azure Entra ID and its token exchange. Let's create these two federated credentials now. It should only take a moment for this to work. And once these are created, that's all I'm going to need from the command line. Now that I have everything in place, let's perform the final step. I'm going to switch back to my GitHub repository. Now I'm already in the settings page, so let's drill into secrets and variables, and then choose actions. This allows me to create repository secrets, and I'm going to create 3 for each environment. The first will be called Azure Client ID, and it will contain the app ID variable I created earlier. Note that I'm just copying the GUID itself without any quotation marks or other characters. The second secret will be called Azure Tenant ID and will contain the tenant ID variable from before. The final one is called Azure Subscription ID and will contain the subscription ID, but I'll leave that last one as an exercise for the viewer so that I'm not pasting my subscription ID on screen here. That's going to do it for today's video. Over the course of this video, we created a secure mechanism for Azure Entra ID and GitHub to communicate with one another, as well as creating credentials for us to access an Azure Machine Learning workspace and execute ML pipelines on it. Next time, I'll dive into GitHub Action workflows a bit. We'll see how to create these workflows, what kinds of options are available to us, and how we can use one to run against Azure ML whenever we check in new code. We'll have links and show notes in the description below, and until we see each other in the next video, take care.